Okay, let's start, I guess. So, very good evening to Miss Richa and rest of the participants. So, it is my pleasure to introduce Miss Richa Singh, Senior Geotechnical Engineer at Aegis Engineering Private Limited, and a highly accomplished professional in the field of geotechnical engineering. So, Ms. Richa has completed her PhD from IIT Kanpur, where her research focused on slope stability, soil stabilization, climatic effects on soil behavior, and reliability based geotechnical analysis. Her work has led to SCI and Scopus Index publications and an Indian patent for an innovative device developed during her PhD work. She holds an M.Tech degree from IIT Roorkee and has also worked at IISc Bangalore with Professor GLS Babu, the one who is so esteemed one. She has served as contractual faculty at NIT Raipur and gained significant industry experience during her tenure at Atkins. Ms. Richa has received several recognitions, including the first prize in the ground improvement category by the Indian Geotechnical Society. She has also received the esteemed Prime Minister Trophy Scholarship during her bachelor's. So we are delighted to have Ms. Richa Singh with her diverse background from such prestigious institutions with us today, and we look forward to her insightful session on sheet pile walls and pile foundation in infrastructure projects. So I heartily welcome you, Ms. Richa, and I will hand over the mic to you for the session.
Okay, thank you so much, Aditya, for the brief introduction. And I'm very delighted and glad for getting the opportunity to speak and to share my knowledge, which I gained during the industrial experience of about right now 4 to 5 years. And it has been a while when I joined Agus, and I had an opportunity to work on the pile rafted foundation also, which was not a part of curriculum and still not a part of curriculum in geotechnical engineering right now. So this session will give uh, a brief review of how to handle such projects in the field conditions, how to handle the situations, what are the basic parameters, what are the design parameters we should consider for the design. So this is basically how we work in the field with the field parameters and how the sheet pile wall and the pile rafted foundation should be designed. So now I will be sharing the presentation and sharing my knowledge through it to all of you. Um, so here I'm sharing the screen. Let me know if it is visible.
Yes, ma'am, it is visible.
Okay. Okay. So starting with the here session, which is on the fifth day of FDP, the second session now. And till now, of course, you have gone through many sessions which have given the knowledge of how to collect the data, how to get the random values for the field, and how to generate them, how to analyze for so many data and handle when there is a vast variation in the data. But now it will be an insight here how we have to collect the data and what are the data to be collected and how it is to be implemented for designing the field parameters. Okay, so going further to the brief introduction of the comprehensive program of the session here. First of all, we will go through the introduction about the sheet pile in the first section and the classification of the sheet pile walls and the theories, which is the most critical condition for design and why it is critical, and then the design approaches for different sheet pile walls, and we will take the case study. how to design the parameters, how to design the whole structure in itself. And in the section 2, we will be taking the conceptual understanding. First of all, how it is different from the conventional pile and the raft foundation, and what are the mechanism for the load transfer, what are the advantages, why and in what condition we should opt for pile raft foundation, the design methodology, and a brief soil structure interaction for in plexus for how to design the pile raft foundation if it is sufficient to take the load conditions. So taking ahead from here, the outcomes from the session at the end, you will be able to address what which moment should be taken for design, which section will be better for the sheet pile wall system, which if you should consider more the serviceability limits or the bearing capacity limits, which will be more which will give more realistic designs, and how like in the field condition we can estimate the rough depth, so that there will be a trial which can be taken from the initial stages to opt the optimum design for the section. So we will learn in this. And in the pile raft foundation, first of all, there will be learning on what is the difference between the pile and the pile raft foundations, why it is more advantageous as compared to pile or only raft foundations, in what conditions it is opted, and what are the SSI steps in Plexus. So we will go through them very briefly, and I hope many of you have designed sheet pile walls. Even during bachelor's we used to study, but we don't get an idea that how we should take the section, what are the basic section which is available in the market, and how to optimize that section, right? So we will go with all these steps one by one and learn how it is opted. So first of all, the section 1, it is bifurcated into 4 parts: theory and classification, the earth pressure analysis, in which I will be elaborating about the condition which is more critical in nature and why it is more critical, and the design methods, and then I will take the case study. So coming to the introduction of the sheet pile wall, here in the right side, we can see the slender columns of the steel sections, which are the sheet pile. These are sheet piles. These are the wing walls, and these are in available in market in different shapes: in Z shape, in D shape, in U shape, and these are having like for example here it is U shaped. So here from the corner they will be interlocking each other, from which they are able to make uh, differentiate between the two types of soil. So here there will be with this we will be able to provide the excavation support. Also in the case of waterfront structures, it is used for making the quay walls, for the coffer dams, for keeping away the water from the construction site, for river training and the flood protection system. So, coming to the uh, classification of sheet piles wall, it actually depends on many types which we have already discussed. That is the geometry, the usage, the where it can be used. For example, the material. So it will be depending on where it has to be used. So depending on the usage, we decide on the material type. For example, if it is water body nearby, or soil is not resistant, soil is having corrosion property, so we go for vinyl. So it depends on actually four frames, and these are by material we can select. By the support system, if we are having, for example, the load at the top, as well as there is um, there, after the divide wall on the dredge line only we are having the load conditions, then we can go for cantilever walls. But if we are having the load even on the non-excavated side, that is on the active side, then we have to go for the single anchored or the multi anchored system or the braced excavation system. So it depends on what is the usage and how much load is coming, where is the load coming, in which side, if it is on the active side or the passive side. And by the section arrangement also, there are classification based on Z sections, U section. It depends on how much flexural modulus we want, or how much capacity of the bending moment it has to resist. So based on that, there are different piles and we can choose the section. So, with his coming to the analysis, so which is very critical in nature, there are two type of analysis. Being a geotechnical engineer, we all know that there are two analysis: drained and the undrained conditions are there. And with time, there is dissipation in the pore water pressure, and therefore there is reduction in the passive earth pressure, which will be resisting the active earth pressure from opposite side. So beyond the dredge line, there is passive resistance, which will be acting against the active force, which is coming from the soil, which will be pushing the wall away, is to be balanced. And this is more critical in nature in the drained condition, because of the pore pressure, because of the reduction in strength with time, which get deteriorated with time. So there are different approaches of analysis. In industry, we directly go for some software. There are FEM software, as well as um, which is moment equilibrium or the force, which are based on force methods. So here, first of all, I will be taking the simplified approach, which is used in the field for determining the depth in very simple conditions. So in this, the moment is taken at the bottom of the cantilever pile here at the bottom, and the um, at in the passive side, the forces are uh, drawn for the soil which is resting there, which is resisting the active force, which is coming from the retained soil. And after equilibrium of this force for both of the side, we determine the centroid and take the moment about the bottom to determine the height of excavation, or height of the pile here. So this is the one of the most simplified method which is used. But um, if we study the other type of sheet piles like the cantilever and the anchored system, there are differences. So first of all, when we are taking the depth, we need to adopt for one trial embankment depth. So we need to consider the depth of embankment depth as the zero point 0.5 or zero point 0.7 times the excavation depth. And it depends on the soil totally. And taking the moment at about the bottom, we get the embankment depth and therefore the total height for the sheet pile wall. So in this way, we get the factor of safety, and if it is in sufficient limit or not, we check for it and determine the final design depth with iterations. Same happen in case of the anchored sheet pile wall analysis, in which we take the embedment depth as zero point 0.5 to zero point 0.7 times the excavated depth, but the total height of the pile is taken from the anchored height. For example, the anchoring happens, let me show you here. For example, the anchoring happens here, and this is the depth. So this is the depth which has to be taken for taking into account the moment, while in cantilever we take the full height of the sheet pile wall. Coming to the thumb rule, which is opted in the field for taking the trial depth or the length of the sheet pile wall, it depends on the friction angle of the soil. So in this way, we just opt for the trial depth, and with iterations and the analysis, we arrive on the what can be the possible and more optimized depth for the sheet pile wall. There are more parameters of optimizing and taking the correct value of the depth, which I will be showing you through the Volep software, that how we can uh, fix the depth of the sheet pile wall. So what happens if there is insufficient depth of the sheet pile wall? There will be less resistant to the active side of the soil, which will be pushing the wall away from the soil. And therefore, optimum depth, if we see the last figure, it need to be such that it is able to stabilize the destabilizing force. So always the factor of safety is the ratio of stabilizing to the destabilizing forces, and has to um, it has to be in a safer range for optimum design. So with this, coming to the case study for the sheet pile wall system, this is the region of Scotland, and in this the um the objective of the project was to connect the road from one part, from the north part to the southern part, and that is the Scotch corner. And the motive was not to disturb the agriculture and the livestock which is moving, and still maintaining the flow of vehicle, and there is a high traffic condition there. So basically the objective was to pass these vehicle without any disturbance to the livestock there. So the design challenge in this project was the live traffic surcharge, which was very high in one section of the corridor. And second challenge was the design life, which has to be maintained during the selection of the section, and being in the serviceability limits. So here, how it has been overcome is that rather than having one prop at the top, we provided one more prop at the bottom. So there will be um, that structure will be more stable and having a lesser destabilizing moment. I will be showing and sharing you how it is taken and how it is constructed. So before that, let's learn what are the design outputs. First is the material grade, which we will be taking as the trial, the section modulus, And according to the corrosion allowance, we will be checking if the material grade satisfies the section capacity or not. And after that, we will be taking one trial embedment depth and find out the moment and the factor of safety for the proposed depth, and then optimize it with trials. The other two steps are taken care by the structural team, as it is more relevant for the construction and site. Coming to the structure here, if we see, this is a box kind of a structure having four wing walls in both the sides. And this is the length of the corridor, which is about 21.5 meter. And this is the total clear span, which is about 4.3 to 4.8 meter. And the skew angle was 0, means there is no skew for this geometry. And there are four wing wall section which is taken at both the sides. In north abutment and the south abutment, there are two type of sections taken, taking care of the load which is upcoming from the top. So in the south abutment, there is high special load conditions which was coming due to the traffic, which was taken account while giving the surcharge. But here in geometry, because of the high load condition, the slab is provided at the bottom as well as at the top. Top is the it will act as a vertical one prop cantilever. But if we are providing one more reaction here, there will be two props. So for this, the design has been done. And for if we take the site conditions, south abutment is having the engineering backfill of thickness 8.8. The challenge here was the north abutment. When we are uh, driving the sheet pile wall in the north abutment region, it is directly driven in the weathered sandstone, because here the thickness of the engineering backfill itself is 4.8 meter. So directly in the passive side, if we say, it will be directly encountering the Penrith sandstone, while here there is like a 4.8 meter of thickness, it is getting at the top itself. So the section which is at the in the north abutment, it is very crucial. We will be seeing here more the assumptions which has been taken before the analysis of the condition is the design life, which is considered as 120 meter, the total retained height as 4.8 meter for both north and the south abutments. The groundwater level is taken as 150 millimeter on the active side and 1 meter in the passive side. And in the rigid boundary condition, in that we assume that the wall depth, it is 1 to 3 times, actually we take 2.5 times the total wall length below for the sheet pile wall for the first trial purpose. So that is how is the trial abutment depth taken and then optimized according to the moments. So I will be taking you to the software, how it works, and what are the input parameters in this. Before that, I want to show you, because I am not having the software right now installed in the system. So here, this is the manual for the software, and this is if we go to the method of analysis, we can see that there are four inbuilt methods for the factor of safety calculation which it takes. That is the strength factor method, Berlin Potts method, and the British code method, and the piling handbook. So since this is based on the Scotland, we have considered the Eurocode 7, the strength factor method, and the factor of safety is taken care by the software itself for two types of analysis. There are two types of analysis which is done. One is the set B and set C always, and in most of the cases, set C or the DA1 C2, according to the Eurocode, is more crucial in nature. And here, I would also like to share with you, with the help of one video, that how is the interface for for this software works. So this is the interface. In this, we can see. Let me share with you. Yeah, in this we can see that we can input the layers of the soil from the strata tab, the soil types, the property about the strength properties, about the other core pressure parameters from the initial groundwater levels, and the stiffness of the wall from the wall tab, and from the struts, if struts are present, then we can input the struts property also, load conditions according to our load, and then the surcharge if it is a dead load condition, and the UDL for a defined length. And these are the stages. There are some inbuilt stages in the software. So I want to show you that what are the stages, because that is very advantageous in nature. So yes. So here we can see there are some inbuilt stages here which we can put, that fill on the active side and excavate on the active side, fill on the passive side, excavate. So directly it will take into account if it has to excavate on active or the passive side, and we can directly input the depth, and if there is load we can put the load. It will directly take from here. And then in the factor of safety option, we can opt for which method should be adopted. So here we are opting for the strength reduction factor method. So let's see in the next step of factor of safety option. Yeah, strength factor method. So there are other methods also, but according to Eurocode, we are selecting the strength factor method. And then in the bending moment option, we will be selecting subgrade reaction model, and then it used to give the output from which we can determine if that depth is sufficient for the bending moment or not. I would like to share the result which was done on the same analysis. This is the result which I got from the software after doing the analysis. That is the same problem which is taken in the video. And if we want to draw that what is the optimum depth here, so below in the analysis, we can go here to the bending moment and the shear force diagram and see that the maximum bending moment, it is occurring here, and the values, let me show that the values Yeah. So here, the factor of safety is 4.14, and the if it is taking the factor of safety as 1, then it has to do the take the elevation in the passive side as minus 6.4, or otherwise it is minus 3. So it is very high because now the level is higher as compared to this one. And with this, if we want to analyze the depth, what is appropriate, so here we can see that uh, the displacement is almost coming 0 after minus 3. Okay, and the bending moment is also coming almost 0 here, but here it has increased. So we can take the depth of about 17 or 17.5. With this value, we can uh, guess that, okay, for the first trial, we can also consider 7 or 9 meter. But this depth is not optimum. This is like every time we get confused after seeing when it is getting or reaching the minimal value, and then suddenly it start increasing the shear force also. But we need to check again at higher depth what is happening, and then choose which is the where it is reaching the minimal value, and then take the optimum depth according to the bending moment as well as displacement. So this was the result, and this is how we used to optimize the depth of the sheet pile wall. Coming back to the slides here. So the further is how to input the loading, and what are the structural conditions which we should input, and how to choose the section for first of all, because when we are choosing the section, it will be taking the bending moment accordingly. So this is taken from one of the site which build the sheet pile sections, and we can see the details here. Let me show you. Yeah, this is the moment of inertia, the section modulus, the wall width, and the total section depth. So once we are designing, for example, for the 120 years, so according to the standard codes, we determine what will be the corrosion loss over that years. And accordingly, first of all, we find out the bending moment which will be coming. And if it is uh, like higher than the upcoming from due to the load conditions, then the section is not satisfying the load capacity value. And if it is, for example, in this case, it is higher as compared to the load, uh, the moment which is caused due to loads. So this is like okay, like we can say that it is okay section, and we can go further with this section. So for the load conditions, there are traffic loading. Here in this case, there was a special vehicle load which was taking into care the higher axial traffic loads. So here for the higher axial loads, we have taken 30 kilopascal of load conditions, and then the steps in the wall app is done. So let me share with you that how the steps are done. First of all, we input the strata, the properties for each of them. And then we input the sheet pile wall, the properties like the flexural rigidity, EI value, and all for the sheet pile wall, the groundwater level. And after inputting these values, we input the deck slab, the thickness for it. We input it as a concrete with a thickness of, for example, here 1 meter or something. And then uh, at the bottom also there is a deck slab which is taken into account. So from here we are having two prop forces which is upcoming and resisting the active force from the soil here. So this is the dead load surcharge, which is 10 kilopascal. And then in the next step, we have input the live load surcharge. And then the prop and the moment forces, they are applied in the last stage. And we get the results for the bending moment, shear force deflections, and we choose the optimum length or the height of the sheet pile wall. So this is the result for different analysis which is carried out to optimize the depth. So this is like the set P and DA1C2 according to the Eurocode. We call it as set C. And this is serviceability condition. And this is accidental condition. And according to all these conditions, then we optimize and take the most critical condition and take the choose the section according to that. So these were the steps. So with this section ending, we learned that how to find out the moment for the sheet pile wall, which will ultimately give us the height and the maximum bending moment for the sheet pile wall. And also, with this, we learned how to choose the section and what are the critical um, moments, the maximum moment which has to be satisfied for the from the section and the section capacity. So this was the learning and the step by step procedure. I hope that you all will be able to now work on the Wallap software if given, and it will make the steps very easier to take further. Coming to the section 2, the pile raft foundation. This is the combination of pile and the raft foundation in which we strategically um, distribute the number of piles and the position for the piles according to the requirement, and therefore it is economical as compared to conventional piles. So the fundamental concept behind the pile raft foundation is uh, there is some load which is taken by the raft and some load it is taken by care by the piles. The most I would say that 30 to 50% load it is taken by the raft, and since the soil around the raft is not um, having the capacity enough to take the load conditions of the site or the building, then we go for the pile group at the bottom also, and this will be fewer as compared to the conventional number of piles which is required. So with this, what are the advantages? There is reduction in the number of piles up to 30 to 50%, and raft also carries some portion of the load through soil contact. So we are able to reduce the load to coming to the piles. There is reduction in the total settlement and the differential settlement, and of course because of the raft there is reduction in the differential settlement all around the construction area. And with this, moving further, understanding how the load sharing is done in pile rafted foundation, there are four different ways through which the load sharing happens in case of pile raft foundation. The raft soil contact pressure is there, then pile shaft friction is there, pile end bearing friction pressure which is taken by the end bearing, and the pile raft soil interaction that is there. So there are four different ways from which the load get distributed in the pile raft foundation. And in this way, there are advantages which we have already talked about. There is reduction in the piles, about 30 to 50% fewer piles are required. There is reduction in the construction time. There is reduction in the material and the installation cost. And in case of large project, it is a huge saving. And there is enhanced performance due to reduction in the settlement, due to improved load distribution, due to better performance under eccentric and non-uniform loading cases. So, with this, if we want to understand where it can be used and where it cannot be used, so the ideal condition to use is when the soil is, for example, I have encountered during my experience that pile rock foundation is used mostly in the region of where the topsoil is silty in nature, and then we directly encounter the rocks. And in Middle East area, most of the strata is having hardly 4 to 8 meters the top height as silty, and it is not very soft or stiff in nature and not very soft like clays. So we cannot rely on such soils for taking the load, and therefore the shallow foundations um, are rare in case of Middle East regions. And nowadays, for high-rise building, pile raft foundation is the most opted foundation system in such cases. Due to the layered soil profile, there is increase in stiffness with depth. There, in case of very high-rise building, for example, generally in Middle East, we go for minimum 30 to 50 floors of building. So there, the raft foundation with this kind of soil will not at all be suitable, and therefore they are opting for pile raft foundations, and where it is uneconomical. So the typical application which we see, that in case of high rise residential areas, the commercial buildings, the industrial, the bridge abutments, approach embankments, the tanks, power plants, etc. Now, where not to use the soils which require, for example, the topsoil which is very, very soft in nature, and the depth of the rock is very deeper. Uh, the like stiff soil, it is very deeper in strata, then we have to go for 100% pile support, and where the sites are having aggressive corrosion conditions, because every time we have to check for the pH, for the chlorides, before going for construction of any such foundation system. Structures which is having extremely stringent settlement criteria, and the small structure where design complexity is there. So with this, moving into the what is the design philosophy and how it differs from the conventional pile design. So for the pile rafted foundation, we opt for the serviceability criteria or the settlement it is mostly controlled by the settlement criteria, not by the bearing capacity criteria, unlike what we do in the piled foundations. And here we can optimize the number of piles after one or two layer of trials if the bearing capacity or the factor of safety is too high. And the key principle in this is to utilize the raft soil contact capacity and um, reduction in the settlement. So, coming into the analysis methods, there are different analysis methods. I myself have undergone two different computational approach during my experience. First, let me share one by one. So first here is the simplified method in which we can directly take the raft as one foundation and the or pile as one foundation, and the rest, if it is taken care by the raft, we can check on it. So that is one methodology, but that is very wrong. Coming to the second uh, method, that is plate on springs. So in this, we opt for the Winkler spring method, and with the help of load settlement curve, it is very convenient to opt for this design as it is totally based on the graphical approach, and there is not a lot of computations involved, but this is linear in nature. Coming to the third one, the boundary element method. In this, I have worked on when I was using Repute software during the analysis. And this is very different as compared to the regular Plaxis or the FEM analysis. In this, we input the soil condition, the concrete, the type of the concrete, and then the borehole log layers, and then the number of piles, the force which is coming, we can give the coordinates directly, and then analyze this to find out the pile capacity at any depth, and then determine if it is sufficient or not. But this method is based on BM method, which means that this whole element, it is considered as one. It is not considered as like the nodes, or the load will not be shifting one by one to the nodes. It will be shifting uh, like for the full element itself. It will be taken care. So this is um this gives the bearing capacity on a very higher side as compared to the what is the realistic value. Coming to the FEM analysis, or which we do in Plexus, we will go through it one by one. We can capture there the non-linear soil behavior, which is very important, and the more realistic conditions. And nowadays, it is coming the hybrid method, in which BM and the finite element both are combined, and the linear and the non-linear zones of the capacity is taken care. So going further, these are the design parameter which are input for the soil, and for the uh, concrete, the stiffness values are taken as input in Plexus. And for the piles, we all know that for the general analysis, we need diameter, the stiffness value, the different material type, everything need to be input. And then the step-by-step methodology for this, let me show you in Plexus. So this was a 58-story building in Dubai, and here from here we have input the soil properties, different stratigraphies, and there are, for example, seven soil layers, and the structure, that is the piles. There are about um, 200 piles in this, and if we see here, we can see that there are 8 groups. So each are having like different numbers. For example, this pile is different in diameter as compared to the P1 and P2. So in this way, there are different piles, and the coordinates are given directly by the coding here, and we have taken the point loads, and after this, after forming the mesh, it is very slow. It took almost 1 day for analysis, and that's why it is very slow in nature, the whole analysis. Mm, Stage construction. This is the calculation results. So it will take a while. So from this, we are able to get the load at different points, the settlement at different points with the load and settlement curve. Then we optimize that if it is within the bearing capacity for the whole raft and the piles, if it is um, taking the load conditions or not, and we design on the size of the foundation. So how to optimize the file placement? First of all, the placement of the file is done for about the distance of 2 to 4 meters, and the between every 3 to 5. It depends, it depends on the pile diameter, and then we concentrate more pile under the load conditions and on the edges to restrict the to restrict it from the differential settlement which can happen at the edge and the corners, and there are clusters where we see there is a high settlement due to the loading conditions. We uh, we concentrate more piles in that zone. So here, if we see, it is giving here 77 millimeter of the settlement. So as we are moving with the settlement criteria only, so we decide that if it is on the serviceability limits or not, and we go further with the arrangement of piles. Moving further on this, there are different settlement criterias according to the codes for residential building, according to what kind of building it is. There are different settlement values, and according to that, we can check on if it is under the permissible limit or not. So, this we have already seen in the software. And then what are the challenges while practical implementation? First is the pile installation sequence. What can be the sequence for it? So before it is not like we have just designed the pile and the raft, now we can go for it. No, it is not like that. We get the layout first of all. We go for the shoring design if there is nearby some water body or something, and we concentrate on the piles at the edges. And then how many number of basements are there, then how many layers will be required for giving for example, I have worked maximum on the three basements layer till now. So we do with two layers of piles. In that case, maximum two layers of pile do work. So there are different steps before going into direct implementation of the construction of pile raft foundation. We have to design for all of them, for the neighbor building, the reactions, the forces which is coming from the neighbor building. We have to see how much force it is coming. So there are different challenges before before taking any construction steps. And then the pile raft connection details, which is if it is adequate or not for the load transfer, we have to concentrate on that. And the raft construction staging, three because we are giving basements. So if we require two level of piles, then we have to go for three level of excavations. And in that three excavation steps, the analysis will also be performed. Let me show you here in Plexus also. We have done in different stages. There are different excavations. These are different depths, which is first of all excavated, and then the this one was filled, and then we have given the piles, and after that the raft here. So that was different step which was taken care during the construction. And accordingly we do the analysis also according to the construction stages. And then the dewatering which is done, and the quality assurance, it is taken care at the site. If there is a pile integrated testing is conducted, if it is coming appropriate or not before construction of the pile rafted foundations. And if there are appropriate number of instrumentation and monitoring system at each levels, if it is there or not. So there are different steps for it. And the challenges which are encountered for the mainly the pile rafted foundation is excessive settlement. And the careful settlement analysis means how what number of settlements we have to calculate. It is not like only two or three compression and the creep value, and we can consider not the two or three. We have to consider different layers, and with that how much settlement it is coming, at which depth it is coming. Everything is taken care while designing. So this gives us the whole holistic economic analysis and the optimization for the whole project in all these steps. So there are iterative steps for the first of all the number of piles which has to be given, then we reduce it to 20 to 30%, then again check for the performance, adjust the pile arrangement, length, coordinates, and then check for it again check for the cost per unit settlement. Again there used to be marginal cost for additional pile if it can be rather than, for example, today itself we were undergoing that problem that if we are having 900 pile on one side of the wall and in another we are having 600 millimeter diameter pile, so how to integrate the uh, the construction there. So there are methods like fillers, or there was another method that we can increase the diameter only at that point. So in that also we need to again see what will be the more economic approach, if it will cause anything um, unusual to the neighbor property. So there are different challenges with all these large projects. Coming to the future trends and the research direction, if we speak about, so still there are work going on how to optimize the pile length, pile coordinates, as well as it is in industry we always go for the optimization of time and the quality. The most important aspect is optimization of time and the quality. That so for that sake, there are usage of machine learning. There are usage of construction stages to understand the realistic conditions, and with the help of sustainable material, if this hard work can be reduced. So there are different methods which are taken in industry, and at last we arrive into the conclusion that we should go for this methodology. And then what are the essential principles for practice? There are first of all, we have to see that pile raft utilize the load sharing fully. That pile raft and soil, all the three should be taken some percent of the load, and then reduce the pile quantity. The design philosophy is always for the pile rafted foundation is settlement controlled, and then there used to be iterative analysis, and with this we go for the economic analysis after this, and we see that how much we are able to reduce with the number of pile reduction, and um, still we are doing the FEM analysis only, and we are trying for the best realistic analysis which is possible, which will give us more realistic values. So in summary and the conclusion, I would like to say that we have learned about both of the most used piles in the industry right now, that is sheet pile walls and the pile rafted foundation, their theory, their construction method, and how to analyze them in the software, what are the design parameters, what are the output parameters. I hope this session has been helpful to all of you, and if there is any question, then please approach, and you can write to me through mail, and we can discuss on it. So, is there any question?
Okay, dear participants, if you have any questions, you can raise your hand. For any queries, please raise your hand so that we can direct the questions to the expert.
For any of the analysis, if you come any problem in the analysis in future, you can always contact me through LinkedIn, or you can write to me through email. We can discuss on it. I am open for it.
So, Richa, what was the model property used?
Model property for sorry, in Plexus,
Yes.
we use the soil property and the model, the Mohr Coulomb model mostly we use. Yes, sir.
So, Richa, how did you consider the interface?
Mm, so for taking the piles as well as raft, uh, excuse me, sir. I would like to ask that are you talking about how I have taken the interaction between the pile and the raft?
Yes, yes.
Okay. So basically, what we do that we make an integrated like geometry for pile and the raft in CAD file, and we directly import it in the plexus. So geometry once is included in the plexus, then we input each of the parameters for pile as well as raft if there is like because there is an integrated like material. So obviously most of them are having the same properties. And then for boreholes, we are having in plexus like with the help of boreholes here from the soil, we can input the, for example, we do the create borehole. So in that we can input with the help of materials, import soil, and in this we go. Then we can input all the properties for each one of the layers.
So, for the properties, like you have taken soil to the laboratory, or you have these values through some research paper?
Actually, so this is the project in Dubai. So we are having contractors. So all the steps are taken before like getting the properties. We go for bidding, tendering, and then get the contractors and get them done the GI investigation and the field and get the reports, check them. So with that, like they do laboratory as well as field investigation, and we get the values for each of the region. So I'm not able to hear you.
I think we have one follow-up question from Dr. Plavandev. He's expert in geotechnical engineering and worked on a large scale with Raft Foundation.
Yeah, yeah, sure, sure.
Uh, Good evening, ma'am. Am
Yeah,
I audible
hello.
to you?
Yeah, yeah, hello.
Yeah,
Good
as you
evening.
mentioned that that is the field-related project.
Mm-hmm.
So I want to know that how many piles are inserted below the raft?
Below the raft, there were about 28 files. No, 200 files. Wait a second.
Yeah,
Let me
yeah. Okay.
show you. So, mm, actually, because of the software, it has gone so slow.
Okay, yeah.
So these are the numbers. See, like what we do that we classify the number of piles. So, for example, this is the 1500 millimeter diameter pile, and other can be any other diameter pile, and it is having some specific value. So, this thing we input by coding for each one of them, and we directly give the number of piles for them. For example, this type of file is 62 in number. This type of file is 12. This is 26. So, like that.
Okay, ma'am. And what is the maximum story number in that building or high-rise building?
This is 58. story building with three basement, but it depends. Like I have even um, taken care for 101, and that I didn't model in Plaxis, but I
Okay,
went
okay,
for
okay.
the repute. Like
Okay,
I mean,
just I want to know that is there any combined action analysis has been studied before the construction of this
yeah,
building?
yeah. We used to have the combined like structure and the geotechnical full analysis
No,
used to be there.
just I am asking that combined loading action because that is a high-rise building, so
Yeah,
wind effect will be there. So is there
yeah.
any lateral load capacity analysis has been performed for that?
Yeah. That is taken care to the loading condition. We directly like according to XYZ direction, we directly give it in the loading. Let me show you if I'm having the loading condition here. Mm, okay, here I'm not having the loading condition, but mm, like we used to have the loads in X, Y, and Z direction. So with wind load is also taken care with the dead load, live load, and any of the loads are there. It is taken care in the loads.
Okay, then bending moment analysis has been also performed
Yeah,
for
yeah,
that
yeah,
pile.
yeah,
So
yeah, yeah.
in which phase that maximum bending moment will occur and how you have rectified those things, and that means how you have encountered those things into your this large scale project.
Yeah, we actually get sometimes high bending moment at the edges, and it becomes very difficult to rectify such a problem.
Yeah.
So, in that case, we always go for like the interaction which we have given. Like, for example, mm, so for example, this is the area, this is the whole foundation area. This is not symmetrical in nature. So, for example, I was getting here something, the bending moment, the additional one which was not supposed to be there. Then what we do that we try to change the interaction conditions, or we try to like shift like the load, like some of the times like there are issues in the coordinates of the loads, and otherwise we go for the higher like thickness of the raft or excavation. We used to chase that if we can increase the excavation details, like all these small properties, but um it really takes care about if there is any extra or the unusual thing which is happening. So we used to iterate on that small things and get the values.
Okay. And what kind of interaction properties you have incorporated? I think that is
Interaction.
pile interaction is there, then pile raft
Yeah,
interaction is there. So how
yeah.
you have incorporated those things into this project?
See, it is like, this is integrated thing, like which we have imported. So it is like not an issue. But these piles, we always take it as a embedded beams. And then
Okay,
like a
beam
norm,
element is used. Okay,
yeah,
okay,
yeah, beam element we use for the piles.
okay.
So then we give the negative and the positive that direction for the loads. Like here we use the faces so that the loads will directly be coming on the coordinates which is coming. Mm, let me show you if it is. Yeah, this is the interface. So we give this interfaces. So this interfaces also play a very vital role if we are means the negative and the positive interfaces for the load conditions.
Ma'am, just a last query is there.
Yeah.
How you have chosen the location of pile? Because your raft area is very huge. Then how you
Mm-hmm.
have chosen the location of the pile? Just tell me. Mm.
Okay. Um, for the piles, actually, what we do that let me show you if I am having the recent one open. Mm, this is one of the project in which I am going to do the same thing again. So uh, we get here, um, for example, this is the kind of layout. Okay, this is the layout for the same project. Mm, so okay, wait a second. So this is the recent project which in which now I am doing it from very scratch. So what we do that first of all we do the shoring design because this building here um, it is at the site of the Dubai Canal, and here having a building means first of all we have to have the shoring um, system. So first of all, we design for the shoring, and in this also, since we are having the three basements, so see, this is the first basement. But this is the pile for the second basement, and this will take care. The second pile will also take care for the third basement. So now what we do, we first of all distribute all these pile around this area and for shoring purpose, and for the smaller diameter for the inside one, because this will not be encountering directly into any water body. And then we choose, for example, my building is here, and this is all the staircase, and then here is the building. Then I will choose more pile concentration here, and here for in the first trial there will be the piles, but that arrangement can be like usually we used to take 2 to 3 times the diameter of piles. That distance can be taken, and in the second trial then we reduce that piles uh, 20 to 30% as compared to the normal. So from this kind of region we decrease the pile, and in this way we slowly optimize with the help of, because see we now get the settlement diagram also. So we know in which region the settlement is more, and accordingly we choose if there is more pile required in that area or not. In this way it is like used to be, for each of them 8 to 10 minimum 8 to 10 trials used to be there, and it really takes a lot of time. And yeah, this is how the method is.
Okay, ma'am. And is there any load sharing ratio is there for your final outcome?
Yeah, actually, what happens that pile always because see, we have opted for pile raft foundation because raft is not able to take full load, and even we don't want to give 100% to the piles. So basically, 60 to 80%. What I have encountered, yes, 60 to 80% of the load is taken by the pile, and the rest is taken care by the raft. So in this way, that is how the ratio is maintained.
Okay, ma'am. Thank you. Thank you.
Welcome.
Okay, I think we have one more query from Dr. Aparna.
Yeah, sure.
Dr. Aparna, you can unmute yourselves.
Am I audible, ma'am?
Yeah,
Yes,
hi. Hi,
Hello,
Dr.
Aparna,
Aparna.
कैसे हो?
Am I audible, ma'am?
Yes, yes, you are audible. Tell me.
Okay. Good evening, ma'am. I want to ask one thing that what is the criteria to use anchored and cantilever sheet pile walls? And one more thing is that which code do you follow?
Okay. Yeah.
So
So,
Richa, she is Aparna from PhD from IIT Roorkee, and she
okay.
was the student of Professor N.K. Samadia, sir. And she
Oh,
worked
okay.
on this sheet pile cantilever injection, I think.
Okay, okay. Okay, so you have already worked out. Of course, you must be knowing it very well. But from what I learned from the industrial experience, I would like to share. Um, Aparna, like for sheet pile wall, like for choosing if it should be cantilever or anchored, we depend on the load condition, which is upcoming from the top. If it is like the high load condition, for example, in this case, the case study which I shared with you, it was having some special traffic conditions. So that's why we chose for the anchored one, like not anchored one, it was having prop actually at the top and the bottom. So with the help of the slab, rather than anchoring it, like we were able to provide the prop forces here. But it depends, like if in field we are not having that kind of system, we can go for the anchor or the strut according to the requirement. Hello.
Okay, ma'am. And what about the code?
Code, yeah. So actually, see, it depends on for which country, like we are doing so. So basically, when I was working in this project of sheet file, I was working for UK, and therefore I have used for material properties we use Syria, and for the partial safety factors we are having BS codes. So, yes, Euro code 7 is the main for the partial safety factors, where you can find it discreetly. And if you want to study about like in brief, there is one book on decode for E7, E code, Euro code 7. So you can go for that.
Okay, so for Indian,
For Indian
we don't have
conditions,
any Indian code.
For Indian conditions, I'm not aware, but yeah, there is a IS code for which from which we use the partial safety factor for structure also, the IS code. I'm not remembering the name exactly, the number for it, but yes, I do remember that we used to have dead load live load combinations, from which we used to take the partial safety factors for two type of sets. So there was some IS code for India also.
Okay, ma'am. Thank you.
I think Sagar has raised his hand.
So Sagar, if you have any question to ma'am, you can.
I think we have one more question, or one more query raised by
Yes.
Dr. Sagar.
Yeah, yeah. Sagar,
You
can
can
you
unmute yourself.
unmute? Yeah.
Yes, Sagar, you can
I
unmute
think
yourself and you can ask your question directly to the expert.
I think he's not able to unmute.
Mm, maybe. Sagar, you can also post your question in Q&A. That is also available. We can also take up your query from there. If there is a problem with audio, you can just post your question. Okay, we'll take up Sagar's
Okay.
question. They are in our WhatsApp group as well, and we can have the question addressed to you, Ms. Richa, later.
Yeah, sure.
Okay, so I really extend a heartfelt thanks to you for delivering such an insightful and enriching session. Your clear explanation, the practical perspectives, and in-depth coverage of design, construction challenges, and geotechnical considerations, they have greatly enhanced the participants' understanding of these critical infrastructure systems. Not only this, your expertise and engaging presentation style, it has made the session highly informative and relevant for faculty members, the researchers, practicing engineers, all of them. The valuable case studies that you have showcased, your real world project experiences that you've shared here with us, it has provided participants with a knowledge that I believe will significantly benefit their teaching, research, and professional practices. So, on behalf of the ATAL FDP organizing team, I sincerely appreciate your time, effort, and contribution to the program. So patiently, you have taken up the queries and answered them with such expertise. I thank you for being a part of this initiative and making this session truly impactful. So, thank you so much, Ms. Richa. We look forward to having more interactions with you and hoping for more collaborations.
Thank you so much. Thank you so much for giving me the opportunity to share my thoughts and my learnings with you all. And I also attended few of the sessions, and it has been very insightful. And I would look forward to be associated with such programs with the university. It has been a great opportunity. Thank you so much, Murtaza sir. And he has been my colleague, and we studied in IT Roorkee, and because of that we got an opportunity that to collaborate here. I'm very heartily thank you to you and all the um, associated team for organizing this event and session and making it very successful.
Well, Dr. Murtaza has been the guiding and lighting hand for this FDP. So, yes, cheers to him. Okay, thank you so
Thank you,
much,
Richa,
Ms.
for
Richa.
joining the program and accepting the invitation. And there is an announcement for the participant that tomorrow is the last day of the FDP and the session will start from 2 p.m. onwards. Okay. Regularly, we had the session from 6 to 9 p.m. But tomorrow there will be session start from 2 p.m. onwards and there will be 3 sessions. And there will be one extra hour for assessment and final feedback. And as we have repeatedly announced that there are two criteria to get this AICT ATAL FDP certificate. One is the attendance criteria. So it must be 80%. For now, if you will look your account, by default, it is present for all 5 days. So we have not updated the attendance so far. So from tomorrow onwards, we will update the attendance most likely through MS Team records. Okay. So secondly, the marks in assessments should be 70% and there will be 25 minutes allotted time and link will be activated only for 1 hour. Okay. So we will post in the WhatsApp group also that the scheduled time for the link is 1 hour, but you have only 25 minutes to attempt all the question. There will be MCQ based question, merely 30 to 40. So if you don't get that 70% mark, you may not get your ATAL FDP certificate, and marks will be automatically uploaded on ATAL portal. We don't have any role in your marks. We cannot moderate anyhow. You have to attempt question accordingly. Okay. So thank you. This is the announcement, and I think we shall end up. Thank you, Richa. We have extend 10 minutes more,
Thank you, sir.
and
Thank you
we will
so
see
much.
future collaboration. And you
Yes,
extensively
sure.
work in Plexis. I also work for reinforced granular pies, that geosynthetic, all that under
Okay.
embankment criteria.
That's
So
great.
I think we shall end up this session, and thank you all the participants, and have a good night.
Okay. Thank